Okay, we are going to go through and do the odds out of this worksheet as your notes, and that should hopefully be a good place to get you started with your homework. So the first one is name two pairs of vertical angles. Well, what I'm saying basically is this and this, they're a vertical pair, and these two are a vertical pair. Remember, you have to be sure about the middle letter, but you do not have to worry, like the P and the Q are interchangeable. Let's do the yellow ones first. The angle PMS and angle QMS, they're a pair of vertical angles. And then we can go with the purple ones. Angle PMQ and angle SMR. Those are also vertical angles. Okay, we're using the same diagram up here for number 3. Angle SMR, telling us right now that that's Y. Well, let's just go through and figure out the other angles. The angle up here is vertical. So what do we know about its measure? We know that they're the same, so this angle is also Y. These, on the other hand, aren't vertical angles. They're, if we ignore all this, a linear pair. How many degrees in a straight line? 180. We're taking this part away. This is always a little confusing the first few times you do it, but we have 180 minus Y for those two angles. Whatever this is, you're just going to subtract it from 180, and that's how big the yellow angle is. So angle SMP, 180 minus Y. Angle QMR, 180 minus Y. Angle QMP, Y. Right. 5. Name two pairs of supplementary angles using this picture. There are a ton of choices. What I would do, honestly, is I'd look for linear pairs. So like you have a line, let's just for the first one, there's a line, and you can pick either that ray or the other ray. Let's pick that ray just because it doesn't matter. You could do a different one on your paper, right? So HCF with angle FCD. In HD, notice the altitude, that's the line. The C's match and the F's match. Let's pick a different line. And let's pick this ray just because. We could pick this ray, or that ray, and we would be fine. So angle GCI with angle ICB. That's it. Okay, next page. 7, we got to talk about setting that up. An angle measure is 30 degrees more than its supplement. What is the measure of the angle? Well, the first thing is we know we're adding up two angles, okay? So I'll get two different colored pens going. And we know that's too light. We know that when you add up those two angles, it's equal to 180 because we see the word supplement. So we don't know the first angle, right? An angle measure is 30 more than its supplement. So let's make that the angle. We're going to add that. If we don't know something in math, we just use x. Now this one's 30 bigger than the next angle. So whatever that angle is, if I take away 30, I know my angle. You could also do x plus 30 and x. You'll just have to twist the answer, but you're going to end up with the same two angles. All right, now we just have an Algebra 1 problem. Sorry, it's a little... Is everybody good? X is your first angle. It's 30 more than this angle. So I took the same angle and subtracted 30. They're supplements. They add up to 180. Add 30 to both sides. Combine like terms. So 2x is equal to 210. Divide by 2. And x is equal to 105. What would the other angle be? Well, we'd subtract 30. And we'd have 75 degrees would be its supplement. We want the one that's larger. If you make a mistake and do x plus 30 here, you'd get 75. You'd find the other one be 105. Just go back and reread it. We want the one that's more, so technically we want the 105 degrees. If you really want to, you could put both angles down. I would be fine with that. All right, we haven't talking about justifications a lot. So let's start that with number 9. I know that AC bisects DAB. So I know that this measure is the same as this measure. Well, I do know that, but I need a mathematical reason to say why. And here are my choices. I have to have either a definition, a postulate, or a theorem. And what we're going to do is, you see A and B, I'm going to combine them. So I'm not going to get into the sufficient condition or the meaning. They both say definition of angle bisector. Another possible reason that these two are the same would be vertical angle theorem. The last one, that they're the same as the linear pair theorem. Well, that is what it means to be an angle bisector. So A/B is probably our answer, but let's go through C and D. Those aren't vertical angles. There is no way that these two are the same because they're vertical angles. Vertical angles have almost got to have like this bow tie look. And that's not that. Linear pair, we need a line. That's not a linear pair. Plus, linear pair theorem doesn't tell me that things are equal. They tell me two things add up to 180. So hopefully that's starting to make sense. I know we're just starting up that. We're going to do that one more time with 11. The figure at the right, we're given this. How do we know that the measure of L and P right here, let me use the highlighter, is equal to M and O? Okay, so some of the things we've been talking about in this section, I mean, it could be something else, but we've been talking about angle bisectors, we've been talking about the linear pair theorem, and we've been talking about vertical angles. Linear pair is to add up to 180. It's not going to be linear pair, plus we don't have that line with just one ray shooting off of it. This isn't an angle bisector, we're not cutting an angle in half, but it is a linear pair. We've got a line, we have a line. Now, technically, if you write down vertical angles, I'll take it. But that's not really the reason. Vertical angles just tells us what we have. The vertical angle theorem is what tells us that they're equal. So really, the theorem should be at the end of this. We'll do some of the evens for our bell ringer tomorrow. You are to work on Chapter 3, Section 2, obviously. Your problems are 1 to 22, 25, and 26.